Okay, guys, I'm sorry I'm late. This machine is always, when I get home, it's always trouble and trouble and trouble. So I am back. Um, let's see if we can see if anything is, if I can see myself here in live. I don't see it, so let's try one more time. Okay, there you go. Let's put that away. All right. I'm here. Sorry for a delay. My computer always has problem. My computer always, oops, has problem when I bring it home. Alright, I'll be here for a while in case anybody has a question. Let me start the this is a class if you're here for statistics. So it's I'm a little late. It's 7:21, so I'm 6 minutes late. I'm sorry. I'll stay here for a little bit, just in case you have questions. Let me open the website. Okay, and make sure I have it ready in case you guys final exam review. I have it there. Okay. So I am here if anybody has a question. The time to ask the question. Okay. So okay, I'm just waiting for anyone to. This is for statistics. Remember, if anybody came late to watch, this is for statistics. So make sure that you are connected. If you want to learn statistics, you can always stay online. Okay, so statistics is there. I am waiting for anybody. Let me open this too, just in case somebody has a question. Tomorrow you have the final exam, so it's a good idea for you guys to be doing your homework, your review. That's not what I wanted to do. I actually wanted the calculator. Okay, so let me, before I start doing anything, so let me stay around for a while. If anybody's here, I am here too. Is this working? Yeah, everything is. I don't know. Once everything works, how we get relative frequency and cumulative frequency? Okay, that's a good question. It's a cumulative frequency. Is that the question? Cumulative frequency. And we have also relative frequency. Relative frequency. Okay. All right. If let's bring a problem that has a table. This is a small table. This is nice, so we can actually use that table to explain that, right? All right. So let's bring it into our notebook, and let's explain that. Okay. If this is the frequency, this is the one that we're going to be talking about, frequency. And if we want to know exactly how many people we have, then we have to count this, right? It's called total frequency, and that's going to be let's use that as our next column, cumulative frequency. And cumulative frequency is when you start adding the numbers. So it's 2, and the next number is 5, so that's 7. 7 plus 8 is 15. 15 plus the next number, so you have 15 here, right? 2, 7, 15 plus 10 is 25. 25 plus 4 is 29. So this is total frequency at the end, that number there. But you see how it goes adding up, accumulates. So that's cumulative frequency. That the other question that you asked me was relative frequency. Relative frequency. Okay, what is relative frequency? Relative frequency is when you use percentages to express each frequency. See, here you have 2. Now you're looking at this 2. So that is 2 divided by 29, which is the total. And you can leave it like this. With this division, you divide these two numbers. Or sometimes you can multiply by 100, right? Or just leave it 2 over 25. The next one will be 5 over 29. So it is represented as a percentage. The next one is 8 over 29. The next one is 10 over 29. And the last one is 4 over 29. So that is called relative frequency. Okay, so cumulative frequency and relative frequency, it's both shown there. Okay, let me know, Bo, if this is clear to you. If it is clear, then you can just write something like it's clear. Okay, so let me wait for a moment to make sure that you understand that. Okay, great. So let me wait until anybody has another question. And make sure that you guys are okay. Okay, so okay. Ogive, yes, it's clear. Okay, ogive is let's go over here. Ogive is a type of graph. Okay, it's a type of graph, and we need to graph an ogive. I don't even know if they ask you. Do you know if it's a question, Bo? If it's a question in the final exam that you want to see, or do you know? If you have a question that you want to. Okay. If you have a specific question, if not, then I'll just use the information from here, because ogive uses cumulative frequency. So maybe if I use that will be better. All right, so let's see. No, not a question. No, it's not a question. Okay, so let's just use this anyway. Since you have the question, let me capture that cumulative frequency. Let's copy that into the next page. Okay, make it a little bit smaller. This is cumulative frequency, and we need the x-axis too. We need to copy the x-axis. Well, I don't have the x, so I need midpoints on that. So let's copy that into midpoints. Let me see if I can. I should have copied the whole table. Okay, let's copy the whole table again. Alright, that's the table. And now we do have the cumulative frequency. Cumulative frequency. So we have 2, 7, 15, 25, 29. So if you do an ogive, it would be something like that. And here you have the x, the variable. Notice here I don't have a number. I have a 5 to 9, 10. So I need to get the midpoint to be able to graph this, right? The midpoint on that. So if you have a calculator, you can get the midpoint. If not, you can just figure it out. So it's 5 plus 9 divided by 2. It gives you 7. Okay. The next one is 10 plus 14 divided by 2. That will be 12. Right? As you know, the class width here, which would be also interesting, is the difference between these two numbers. So that difference between two numbers is 5. So if you find this, it's 75. 5 plus 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5, it's 22. 17, I'm beginning to lose my, it's 22. 22 plus 5 is 27. So these are the midpoints. I'm going to write the midpoints here. 7, 12, 17, 22, and 27. And I'm going to use cumulative frequency on this side, right? So here side is going to have cumulative frequency. Cumulative frequency goes from 2 to 29. So maybe I go every, I don't know, every 3 maybe, or every 5. 5, 10, 15, 20, 25. Okay, so let's now do the points. 7, it's 2, so it'll be somewhere around here. The next one is 12, and 12 goes to 7, so it's a little bit higher. Okay, 15, I'm sorry, 17. The frequency, cumulative frequencies is 15, so it goes a little higher. 22, the frequency is 25, so it's 25, so the top, and 27 is 29, so it's a little bit on top of the other one. And then we will connect this. Okay, alright, so we connect them. Okay, that's the ogive. Let's write that down. Ogive graph uses cumulative frequency to graph, and sometimes people just make a little line to begin from 0. Oops, that was a really bad line. Let me redo that one. It's just to mark the beginning, right? But the actual beginning is there. You don't have to. Okay. Guys, have any more questions? Oh, first of all, Bo, was that clear? Just let me know if it's clear or not, okay? Okay, class boundaries. Usually use class boundaries for what do you call histograms, but you can also use it for here. It's okay if you use midpoints here, but if you want to know what class boundaries is, then you have to find what the class boundaries here. So let's just talk about this little piece here. So Ashley, I saw you. So let me just go over here for a little bit and explain class boundaries to Bo. So I'm gonna Bo, instead of using this range, we are gonna find out what else can we do. Instead of using midpoints, we can also use class boundaries. And the way that they do it is that they mark the difference between those 2 points, right? The 9 and the 10, or could be the 14 and the 15. So any of this, you can find the difference between those 2 points. 10 minus 9 is equal to 1, and then you divide by 2, and then it's 0.5. So you're going to use this value. By the way, that will be the same for any of this. You can use it between 10 and 9, 15 and 14, 20. Any of these diagonal numbers will give you this value that you're going to subtract from here, and add here. So you're going to have a new classes. Let's write out the new classes in different colors. 5 will be 5 minus 0.5 will be 4.5, and 9 plus 0.5 will be 9.5. Okay, now 10, that's the new one. This is the new one, and the new one here will be from 10. A 10, you're going to subtract 0.5, so that would be 9.5. And for 14, you're going to add 14.5. Here you're going to subtract, and you're going to get 14.5 for the next one. And you're going to add, so it's going to be 19.5. The next one is going to be, 19.5. 19.5 all the way to 24.5. And the last one will be 24.5 minus 29.5, right? You add it, you subtract and you add. And now if you notice, the new classes, they don't have any space. So when you create your histogram, right, you're going to use those values. You're going to start at 4.5, and the next one will be 9.5. And then the next one begins at 9.5, so you're going to write 14.5. So the next one will be 19.5. And the next one will be 24.5. And the next one will be 29.5. So this is your frequency here. Or you can frequency, or you can use cumulative frequency, right, which we already did, or you can use relative frequency. So instead of using the midpoints, you will use these points to represent each class, right? But most of the time, class boundaries I use for histograms. So it will be very tight. So this histogram finish here and the other one begins there. See, no space, because this ends and begins at the same point. Okay, so now Mr. Bo, we're gonna have to move on to 2 more questions. We have question number 6, and Si Yoon has question number 15. Hopefully, Mr. Bo, it's a little bit more clear to you how we get the class boundaries, and you can also rewatch this video. All right, let's move on to question number 6, please. Question number 6 is in 2 little pieces, I guess. Yeah. Okay, so let's copy this first set of pieces. Alright, so I hope that doesn't come out when I make the copy. Okay, and I believe it continues here. Alright. Alright, I think that's part of 6. 6 has a lot of, okay, 6 has a lot of questions apparently. Alright, so 1 second. Where are we? Oh, there you go. So those are the questions. Maybe I should, okay, answer the first questions first and then the other one. Okay. Any particular, I don't know if Ashley, you there, is there any particular question? Is everything on A, B, C, D, E, F, G, or just a particular part? Because what you do is you need to put this into the calculator, everything here in the calculator, and we're going to find the mean, the median, and the max for the data, right? And we're going to construct a box plot. So just A says obtain a 5-point summary. Okay, if the way that you do it, we got to put it in the calculator. So let's go to the calculator. I mean, you can do it by hand. It's, maybe I'll do it also by hand. No need for that, I guess. We're going to enter all these values in the calculator. Okay, so let's minimize this. Let's go to menu and number 2, and this is where I'm going to put my numbers. 31, enter. 33, enter. 35, enter. 36, 40, 40, 41, 43, 45, 47, 48, 51, 52, 55, 56, 59, 70, 71, 74, 76, 78, 84, 87 twice, 87, and 90, 93. Okay, we have 26 numbers. So we just put in the calculator. Yeah, actually, well, I'll show you both ways because you should know. We'll do calculation, we do one variable, and then you have everything you need here. You get your values there. Let me just check that we have everything. The minimum value here is 31. Q1 is 41. Q2 is 53 point. Okay, that's the Q2 is about 52. Q3 76, and the maximum is 93. The medium is a little bit different than, I have 52 in my calculator, and the back of the answer that has 53. But if you want to do it by hand, which is, it's good to know, because I don't know if they're going to be asked you to do this by hand. So you got the minimum, right? Let's copy the information that we find in the calculator so that we know what values. We have the minimum, which is 31. You have Q1, which is 41. You have Q2, which they say is 52. Q3, which is 76. And the maximum value, we got 76. So how do you do this without the calculator? Well, you have, I think we have 26 numbers. We have, 26, so great. Let's just write 26. Okay, so if we have 26, to find the median, which is also Q2, we have to count 26 numbers. So 26 is an even number. So we have to find numbers that are in the middle. Where the numbers are in the middle? Let's count. Okay, 26 numbers divided by 2 is 13, right? So we got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have to have 13 numbers on both sides. 1, 2, we start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 13 on this side and 12 here, so we have to definitely change it. So this is the number that would be in the middle. Let me see, we have it. So we had I forgot how many numbers, so it's 52 exactly in the middle, because you have the same amount here and the same amount here, so that's when we check that. Okay, so the next number that we have to check is Q1. The maximum is 93. Oh yeah, sorry, 93. Okay, so how do you get the other half? So we got to look at the to find Q1, we got to look at this side first, right? This box here, that's the other half. Then we have to find the middle here. Okay, so I think this is the middle. Let me see how many numbers you have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So Q1 is 41. Now we got to do the same thing on the other side. So if we do that on the other side, okay, we got to find the middle of that side. And the middle of that side without a calculator, that would be Q3. And the middle of Q3 would probably be this number, and we have to have the same number on this side, the same number on that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 76. Perfect. And then the minimum is the smallest number, which is 31, and the maximum is 93. Okay. And if there was two numbers in the middle, you add both and divide by 2. So that's how you basically get minimum and the maximum. Okay. So, Ms. Rodriguez, is that okay, or do you want me to do more? Let me wait for her, and then I'm going to move to C. June that wants to do 15, but I'm going to wait for Ashley to see if it's okay with this. Alright, so we're waiting for Ashley. Hopefully she's still there. Okay, so let's move on to question number 93. Sorry, not 93. Question number 15. No, it's okay. Okay. Question number 15. Alright, where is question number 15? Oh my goodness. Is this question 15? This is question 15. So let's make it a little bit bigger. Oh my goodness, this is a big question. Oh no, this is 15, sorry. Alright, let me transfer that into my notebook. Okay. Alright, this is a question about, let's see, let's read it together. Alright. It says, suppose you pay $2 to play a game of chance, okay, and in which you toss a coin and roll a die. You pay $10 if your coin shows a tail and you roll at least a 5 on the die. Let the air random variable be the profit of the game or the amount of money won or lost per roll. Negative profit corresponds to lost money. Fill out the probability there. Okay, so we have to find out how much money we have to win if you have the situation that is presented to us here. So you have a coin. Let me use a color here. You have a coin, okay, and a roll a die in a die. Maybe I should, yeah, it probably doesn't matter which one you use first, but it's because the die has too many. You have die and a coin. It's just easy that way. It doesn't matter, just for me. So you toss a coin and roll a die. You pay $10 if your coin shows a tail. So you have here 1, 2, 3, 4, 5, and 6, because that's the die. You have 6 chances and 2 here, right? And if you have 2, that means you're going to have 2 from each one of them. Okay, and you have heads and tail, 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 heads. Oop, I think I missed one. Heads and tail, heads and tail, heads and tail. Number 5, heads and tail, and this is heads and tail too. Okay. Okay. Oh my goodness. So let's see what the question says. The question says that you win. You are paid $10 if your coin shows a tail. So if you have a tail and where are we? A tail and you're in at least a 5. A tail and at least a 5. So you can have tail and at least a 5. So this is okay. Tail and 5. Also tail and 6 is okay. At least a 5. So that's okay. So that's fine. The only 2 times you're gonna have tail and a 5 and 10 and a 6. So these are the only times because they want a number 5 or bigger. So let's take a look at this. The event, right? Find the probability distribution table. You win or you lose. Okay. So if you win, well, how much money you get? You get 10 minus $2. You bet is 8. And what is the possibility? That will be 2 over 12. How do you know it's 12? Because 6 times 2 is 12. You can count here that you got 12 different ones. If you simplify, that would be 1 over 6. Okay. Lose. When do you lose here? If you lose, then it's going to be, you lose your $2, and that would be the opposite of this. The opposite of 1 over 6 is 5 over 6. Okay. Alright, so if you multiply 8 times 1/6 and minus 2 times 1/6, that will be question A. So that would be 8 times 1 over 6, which is 8 over 6. And if you multiply minus 2, 5 over 6, that would be minus 10 over 6. Right? And you add this to 8 over 6 minus 10 over 6. That would be minus 2 over 6, which is minus 1/3. That if you change that to money, that would be minus 0.33. This is cents. Okay. And if you play the game 100 times, how much? This is loss, by the way, because this is minus. If you pay 100 times 0.33, you will lose $33. Right? There you go. So that's the answer for that. All right, so let's just wait for if it's still there. Who asked me this question? Somebody asked me this question. See you, and I think asked me this question. So check it out if it's okay. Got it. Okay. Okay. I don't don't know if there's another question there. We got 5 people watching, the same 5 people that were here before. Let me know if it's anybody else has another question. Remember, you can always watch this later. Hopefully people will watch it. Okay, number 14, he says. Okay, I think I did everything over here. Alright, 14. 14 has like 2 pages. Where is 14? There you go. Alright, let's begin with this part of the question. Let's copy that there. And let's bring the table in a moment. Let me read this first, and then I'm going to minimize it and bring the table here, because okay, I'm doing 14, so that's the one that you want, right? Okay. All right. Let's see. Suppose you play a die rolling game in which a fair 6-sided die is rolled once. So you have a die, and it's going to be roll it once. A die, right? You're going to roll it as a die, in case you forgot. Very artistic. And you have 1, you got 2, you got 3, you know, that's a die. Okay, so I have 6 sides. 6 sides. If the outcome of the roll, number of dots on the side facing upward, so we're going to look at this side when you roll it, you win as many dollars as the number you have rolled. You win as many dollars as the number you have rolled. Otherwise, you lose as many dollars as the number you have rolled. If the outcome of the roll is odd, so if it's odd, you win. If it's even, you lose. Okay, so we have that. Odd numbers, it would be 1, 3, and 5. Even would be 2, 4, and 6. All right, so what is your profit if the outcome of the roll is 3? So if you use a 3, you win, and you win $3. It's the same number, right? So fill out. So far so good, I hope. So far, every time you do something, you are either winning or losing. So let's bring the table now, because that's what they're asking us to do. So let's bring the table. I think the table is on the other side. There you go. Let's just copy the table for now, and then we'll bring out the rest of the questions. All right, the table is there. Ooh. Okay, I think the table is too big. Let's make the table a little bit smaller. And they're asking me right now, what's the outcome? Well, we know that it could be either a 1, a 2, a 3, a 4, a 5, and a 6. Now, X is what's going to happen. All right? The variable, what's going to happen? Okay, if you get a 1, you win $1. If you got a 2, you lose $2. 3 is even, so 3 is win, is plus 3, and maybe I put a plus here instead of winning and losing. Is you lose $4, here you win $5, you lose $6. Now, what is the probability of this? The probability would be 1 over 6 for each. All of them is 1 over 6, 1 over 6, 1 over 6, 1 over 6, 1 over 6. Fill out the following probability distribution table. I think we did that already. So the next question is, okay, maybe we'll copy that also in the same place. C, D, and E. Okay, so it's there. Let me minimize that so we can answer those questions. Okay, perfect. Compute the expected value. Okay, to do the expected value, maybe I should put this over here. expected value, you need to multiply 1 times, you multiply x times the probability of x. Alright, so you multiply basically these two numbers here. That will give you 1/6. You multiply these two numbers, give you 2/6, 3/6. We have to put the negative, sorry. This is negative, this is positive, this is positive. This is negative 4/6. This would be positive 5/6. And they would be minus 6/6. Okay. You need to add all of this, right? And if we add all of this, and okay, so it's gonna be that would be 1/6 minus 2/6 plus 3/6 minus 4/6 plus 5/6 minus 6/6. Okay, so we should put the negatives first, right? -2 and -4, that would be -6, and -6 will be -12/6. Did I do that right? Yeah, and then let's add the positives. 3 and 1 is 4. 4 and 5 is 9/6. So if we subtract, that would be 3/6 negative, or negative, is that right? Yeah, divided by 2, 1/2. So that's the answer. That's the expected value. D. Explain the meaning of the expected value in the context of this problem. If you play it many times, a person plays many times, on average, they will lose 50 cents. Cents per game. That's what happened, because it's negative. So if you keep doing that, you will lose. If you play 100 times, so that would be 100 times 1/2 minus 1/2, you will be minus $50. So you will lose $50. Okay, I think we have answered that question. Who asked me for Sejun? I answered 14, and then I will do 33 for Luisa. Sejun, hopefully it's okay. Let me know before I proceed to the next question, number 33, that we are okay. So let me wait for a moment. When we use the formula, that formula, is when we have NCX, right, P to the X and Q n minus X. This is for binomial distribution, and you have the problem here that you have different, you can change this problem to be binomial distribution, but make sure you have a fixed number of times, right? The problem with this is that this fails in this problem because you don't have a fixed number of times. You're going to keep playing this game many times. So that right there, you have 4 conditions. You need to have P, you need to have Q, and you have, equal, the probabilities remain the same. All of the 4 things that you have for here, and you need X value. So all of this is okay for this problem. The problem is this one. You don't have a fixed number of times. You can keep doing this many times. That's why it says here a person plays many times. So there is no fixed number of times. The X is how many times you want to win. A number of times you want to win. This is probability of winning, and this is probability of losing. Okay, so that's binomial distribution, and you have to have only two outcomes, right? That's another two outcomes, which is, in this case, you have it. The problem is how many times you're going to play. Okay, so let me wait for a little bit before I move on to question number 33. Okay, see you. We're waiting for you. Okay, so let's just wait for a moment. Okay, see June, we're waiting for you. If you have any more questions before we move to question number 33. Okay, I think Si Jun went to sleep. So if I ask a binomial random variable, so if ask it's a binomial random variable, the answer is only two outcomes. Right. Yes, two outcomes. It could be win and lose. It's okay. The problem is not the two outcomes. The problem is that you don't have number of fixed times here. The problem here is that this is the problem. In this question, this is the problem. That's the problem. Everything else you can do it. The problem is not that. The problem is here. Okay. We're going to move on to question number 33. What's 33? Oops. Press 33. I think, didn't we do 33? Okay. Alright, let's do question number 33 in a different page. I did it this morning. Too bad that I didn't copy it somewhere. Okay. Let's be nice and do it. Alright, so we're gonna have to write the information as it appears to him to get the comments. Look, I don't know what that means. Okay, a researcher claimed, Girasol, I don't know what you're talking about. A researcher claimed that the average speed in certain city is 8 miles per hour. Okay, so that's a claim. The claim is actually that mu in the city, the average of city wind is 8 miles per hour. That's the claim. In a random sample, so let's talk about the sample on this side so that we don't get confused. The sample is that n is equal to 32. That's the sample size. The average wind speed is 8.2 miles per hour for the sample. The standard deviation of the sample, that's little s, is 0.6 miles per hour. Now, the testing is going to happen at 0.05. Okay. Now, this is the question. Is there enough evidence to reject the claim? This is the claim. So H0 is that, and H1 is that is not 8. That you became like a W. It's not greater than, it's not less than, that is not 8 miles per hour. Okay, so first of all, we have to understand that this is going to be hypothesis testing. For hypothesis testing, I have to make a decision. Number one step is T or Z. That's the first question that we want to ask. Now, we don't know, so let's examine. This, I don't know this. The standard deviation of the population is unknown, so I do have the standard deviation for the so remember in our map, if this is, oops, sorry, if this was yes, we will go this way, but if it is no, we go this way, right? So now we ask the question, is the population normally distributed? Well, it doesn't say anything about the population normally distributed. So if it is yes, we go this way, but in this case we don't know, so we go this way. Now the next question is n greater than 30? And the question here is, the answer is yes. It's actually 32, so we use t-values. So that is, we settle that. Second thing that we need to settle, if this is one tail or two tail test. Okay. Apparently this is a two tail test. Okay. Ooh, let's do it over here. It's a two tail test. Mu is in the middle. And why is it two tail? Because it's not equal. That symbol, it means that we are going to be looking at two tails. We're looking at the T alpha divided by 2, T alpha divided by 2. And here we have 1 minus alpha. 1 is, oh, sorry, copying again. This is, they gave it the number. What's the number? The 0 0.5. 0.5, right? Is that what it was? Yeah. So this area is going to be 0.95, and now we need to divide this into two pieces because it's a two tail test. So here we have 0.025, and here we have 0.025. Alright, so what is one tail looks like? One tail, okay, so let's answer one question. One tail is when you have the symbol like this or like this. In that case, let's do both. In that case, this would be, right, that would be for that one. Oops. Man, I didn't want to delete everything. One tail, I do a little line like that so I know it's this direction, and in that way I show you a little trick, it will be that direction. So this would be 0.95, and this area will be 0.5. I don't have to divide it into two pieces. This would be 0.95 and this would be 0.05. So that's how that will look like. Okay, let's go back to our question here. Now we need to use the calculator to be able to do that problem. And I'm guessing you guys don't have a calculator, so I'm going to have to do it myself without a calculator. Okay, let me open the calculator here. So we're going to go to exit here. We're going to distribution T. We have the, oh shoot, this calculator doesn't have the, I need to open the other calculator. Sorry guys, I knew it. That's what I have the other calculator here. Only this is a huge calculator. I hate one. This calculator is so big. Let me see if I can make it smaller. And now, view, gold screen. Okay, maybe I can. Toolbar. I don't need that. View. Sorry, toolbar. I don't need that. Another one, toolbar, I don't need that. View, I don't need that one. Oh, I gotta do the whole thing every time I use this calculator. Alright, so let's bring that calculator here. And we're gonna go to number 2 is statistics. Then we're gonna go to distribution. t inverse. Going to be a variable, and we're going to write 0.025. And we had how many samples we had in this question? It's 30, what, 32, so this would be 31, right? Okay. So the t value will be 2 point, what is it, 2.0395. Okay, so this would be negative on this side and this positive on this side, doesn't matter. This is 0.0395, and this would be negative 0.395. Okay, let's put this away. Now, why am I using 4 decimals? Because I think the maximum number of decimals here is 2. So it's 1, 2. Let me see if there's another decimal. It's 2. So you can use 3 decimals. I thought I had 3 decimals. You can use 3 or 4 decimals. It's fine. Okay, so far so good, I hope. So we are looking at the that. So we're gonna try to. Once you have this picture, then now we're gonna have to get the what's the first one? The traditional method, I think I call it traditional method. Let's try to see if we reject that. All right. Oops. What did I do? Method. Sorry about that. Let's do it nice and neat. Okay, now we need to get the t value for the sample. This is from the sample, and so we can compare it to the one that we harvested. All right, so the t value for the sample would be x bar minus mu divided by the standard deviation square root of n. So let's get those numbers. X bar is 8.2, mu is 8. Standard deviation was the number that they gave me is 0.6, and the sample size, what do we say was, oops, I think it was 32. Yeah, 32. Okay, that's my dog. And if you do this operation, let me take a calculator. Where's the calculator? So let's go to menu, let's go to 1, and we're gonna do 8.2 minus 8 equals to 0.2, and now we're going to do 0.6 divided by the square root of 32. Oh my goodness, where you use square root? Okay, here. Shift square root of 32. And that's gonna give me that number, which is even more. I should have just, you know what? Let me just do divide 0.2. I'm gonna divide it by, I'm gonna use parentheses because I forgot to change the calculator mode. 0.6 divided by the square root of 32. Let's close that. And what did I do? This calculator is so you see that I supposed to put, all right, yeah, all right, hopefully this is okay. No, I hate, because you see that it's outside of 32, so let me see if I don't get an error. Yeah, okay. So I got that number, which is 4 times square root of 2, which is, I hate that, because it's, I gotta do it in my other calculator because it keeps doing that, so sorry about that. So 2 square root of 2 times 4 equal that divided by 3. So it's gonna give you 1.0 86. This is, if you divide 0.6 divided by square root of 32, is going to give you approximately 1.886. Okay, so now we need to compare if this number is inside or outside. So whoop, whoop. So the original t values that we had was 2.0, what is it, 395, that's a negative, and here's 2.0395, that's the positive. So we had that area, which is the critical area, and the number that we found was 1.886. So this number is inside of the good area, not in the critical area. So we do not reject H0. Okay, so that's one of the answers that we can have. We use other methods to pry. Okay, I think that, or they already answered your question. I'm sorry, I was busy doing the question. I wasn't. How do you know it's H1 or it's one tail or two tails? I told you. I think this is one tail. If you don't, this symbol is two tails. Two tails, because you wanted to eliminate the beginning and the end. So this problem is two tails. Right? You reject this side and you reject that. It's not equal, so you cannot accept this side, not this side either. Okay, so that's how you decide. You can also use the other method. So before I use another method, Luisa, I just want to make sure that you have, do you want me to do another method, or just one method is fine with you? So let me wait for a little bit for you to answer me. If one method is okay or two method is okay. Let me wait for a little bit. Okay. It's all right. We are okay. So we wait. Lisa, are you there? All right. So let me know if you want another method, or this is okay, or you can handle by yourself another method. I think Lisa fell asleep. So basically what we are doing here is we are getting the standard, which is the t-values from the problem, and then we are using the information from the sample, which is this, to compare our t-value with the standard t-value to see if we are inside or outside of the area. Okay? So in this case, if we are inside of the good area, not on the green area, which would be the critical area, and then we say we don't have enough evidence to reject H0. We actually accept that the wind on that city is about 8 miles per hour. Okay, so Siyun wants to know is 232C. Okay, so Siyun, we are going to, before you go there, we're going to use two methods. The other one is probably the simple, which is the interval method. Okay, and that we use x, oops, sorry. Okay, Ashley already answered that, but so we have u, and now you have x minus error and x bar plus error. We already know x bar, which was 8.2, right? minus the error. We already know mu is a, and 8.2 plus the error. So now we, oops, I don't want to put error. I'm going to put the actual error there. Now we need to find the error. So I know it's T alpha divided by 2 times the standard deviation square n. The T that we use here is the standard T. So we found out that the standard T was 2.0395, 2.0395 times the standard deviation, which in this case, I keep forgetting, 0.6, 0.6 over the square root of 32, I believe it's okay. So I'm going to actually use my calculator in my telephone. 2.0395 times 0.6, it gives you on the top 1.2237 divided by the square root of 32. Okay, so now I gotta do square root of 32. Maybe I should have used which is 5.65685. I'm trying to use as many decimals as I can, so I have a better approximation. 1.2237 divided by 5.65685, and that gives me approximately 0.2163. So I now got to add this number, 0.2163, and I'm going to subtract this number and see if that's what it. You know what? Let me bring the other calculator because it's faster. Where's the other calculator? That one. Let me bring it. Let's do that. Okay. Let me do the operations here. So that would be menu 1, 8.2 minus, oops, that didn't come out, minus 0.2163, 2163, and that will give you, this side will give you 7.9837, less than 8, less than that, so they won't be 8.2 plus 0.2161. That would be 8.4161. Okay, so again, 8, it's okay, it's between those two numbers, so we do not reject H0. Okay. 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 All right. So that's the second one, the second method. And I think Yun had the question, and that will be the last question I will answer. 32C. I'm going to wait if anybody has a question on that one. Okay. Let's see if anybody has questions. If not, I'm just going to quickly go to 32C. And I'm just gonna copy it, not because I did this in a previous exercise, and see, you gotta see the video. I did this one already, so I recommend that you search the video for that one, only because I spend a lot of time doing it. Okay, assuming the return parameter is normally used, is there enough evidence level of significance to conclude that the current mean retail price has increased? So here they're not using the word not equal or different. It uses the word increase. So if mu was 46 for this problem, a random sample, let's put sample here. Sample is 15, and the mean price for that sample is 48.4, and the standard deviation here is 3.5. Then H of 0 is mu equal to 46, right? And H of 1, it says that they conclude the current retail price of it has increased. The current price is this, so mu has, it says, is greater than 46. So in this case, because the word greater is included there, it's a only not equal, it's greater. So remember, I do like an arrow, so that would be 1 tail. Actually, it's a right tail if you want to be specific. Is yes, Winsu, increase or decrease is 1 tail. Okay, ladies and gentlemen, or ladies. Yes, we see you. That is correct. Increase once right, decrease is left. Okay. Good luck tomorrow. I hope you can make it. I think I did. If you watch the 3 videos, I think I did almost, I would say 60% of the exam, if not more. Okay, plus you add what I did in class. So I hope you have the time to watch the videos if you didn't watch this one. So thank you again. Good luck tomorrow. I hope I see you. Go to sleep early, and be ready for tomorrow. Don't cut yourself close, leave enough time for you to finish the exam. Good night, guys. Have a good one, everyone.